Hi students, in the last class we have discussed about the that is the Fourier transform analysis. Now we are going to discuss about the Laplace transform. So here in your syllabus here you are having only Laplace transform analysis, but you need to know some of the basic concept of Laplace transform, then only you can apply the Laplace transform to different signals. So here just I will run off through all the basic concepts involved in Laplace transform, and also you have studied these Laplace transform in maths also, right? So here just I will run off through all the basics. You just go through all the basic concept. Here we are not going to see in detail about Laplace transform. We are going to just use the Laplace transform in signal analysis. So here first we will discuss about Fourier transform, and then we will go for the Laplace transform. This Fourier analysis uses the summation of waves of positive and negative frequencies, and the Laplace transform employs damped waves through the use of an additional factor e power minus sigma, where sigma is a positive number. This Laplace transform and Fourier transforms are used in time domain is used to convert a time domain function to a frequency domain function. Okay, so here f of t Laplace transform is f of s. We will write like this in that is in Fourier transform, right? F of t Fourier transform is f of j ohm, right? So this is what the Fourier transform. So this represents Laplace transform. So here f of s, that is if I am having any signal, I need to perform Laplace transform which is equivalent to f of s. So integral 0 to infinity f of t e power minus st dt. Okay, here instead of when you compare Fourier transform and Laplace transform, wherever you are having j ohm, it is replaced by s. Okay, so where s is nothing but sigma plus j omega, and s is this s is equal to sigma plus j omega. The same case we have when you consider this, for this sigma is equal to 0, so s is equal to j ohm. This is nothing but ohm, okay, because this represent ohm represent this analog frequency here. In this case omega represent digital frequency. We are going to deal only with analog frequency, so it is ohm. Okay, so where s is equal to sigma plus j ohm in this case, where sigma is a damped function. Okay, so here in addition to this we are going to use this function sigma here, where j ohm is nothing but here it is replaced by s, where s is equal to sigma plus j ohm. Okay, and another cases here the Fourier transform is we can apply the Fourier transform for these waves. When you apply Fourier transform to this waves, what will happen is this is not absolutely integrable, so it is difficult to find out the resultant for this. But in case of Laplace transform, when you apply Laplace transform for this, what will happen is due to the convergent factor, right? Here you will apply e power minus sigma plus j ohm, right, instead of a. So due to this convergent factor e, that is e power minus sigma t, so what will happen is we can able to this, that is the convolutional that is the integral of this is absolute integrable, so we can easily find the equivalent for this. Okay, so this is what the difference between the Laplace transform and the Fourier transform. I will explain some of the important function how we can perform Laplace transform for this. The Laplace transform u of t. So here Laplace transform f of t formula, here it is nothing but f of s. So f of s is equal to Laplace transform of f of t integral 0 to infinity f of t e power minus st. So instead of f of t I am having u of t e power minus st dt. U of t is 1, so 0 to infinity e power minus st. So when you integrate it, you know you will get e power minus st by minus s. When you apply the limit, you will get 1 by s. So this is what the Laplace transform of u of t. Okay, next one is Laplace transform of a into e power minus at, that is exponential. So now here instead of f of t I am going to apply a e power minus at e power minus st dt. Since it is exponential, I can combine it. So when I integrate it, what I will get it, e power minus a plus s into t divided by minus of s plus a. So when you apply the limit, what I will get? I will get a by s plus a. So the next one is Laplace transform of sine omega naught t. Here we can write sine omega naught t as 1 by 2 j e power j omega naught t minus e power minus j omega naught t. Okay, so here Laplace transform of e power j omega naught is 1 by s minus j omega naught. Here it is 1 by s plus j omega naught. So taking LCM, so you will get here s minus j omega naught, s plus j omega naught, a minus b, a plus b. So s square minus b, a square minus b square. So this is a square, this is b square. So when you square it, you will get j square is minus 1, here already minus 1. So plus a square plus omega naught square. So when you simplify, you will get 2j omega naught. When you cancel these 2j, I am getting omega naught by s square plus omega naught square. Okay, next one is similarly we am going to apply for cos omega naught. So instead of the formula of cos omega naught is 1 by 2 e power j omega naught plus e power minus j omega naught t. So you know that e power instead of that is e power a, that is e power at a I am having j omega naught. So here s minus a, here I am having minus j omega naught. So s plus j omega naught, again simplifying. So here we will get this answer, s by s square plus omega naught square. Now the next one is hyperbolic function, hyperbolic sine and cosine function. So sine h omega naught formula is 1 by 2 e power omega naught t minus e power minus omega naught t. Similarly cos formula is 1 by 2 e power omega naught t plus e power minus omega naught t. And I am going to find out Laplace transform of sine h omega naught t. So which is equal to 1 by 2 Laplace transform of e power omega naught t, okay, minus Laplace transform of e power minus omega naught t. Okay, so here 1 by 2 is common. The Laplace transform of e power at is the, here instead of a I am having omega naught, so 1 by s minus omega naught minus 1 by s plus omega naught. Okay, now when I simplify, this is a minus b, a plus b. So a square minus b square. So when you take LCM, it will become s plus omega naught. So minus already here s minus omega naught. So minus s plus omega naught. So which is equal to 2 omega naught by 2 into s square minus omega naught square. So which is equal to omega naught by s square minus omega naught square. So this is what the the Laplace transform of hyperbolic sine. Next one is hyperbolic cos sine h omega naught, that which is nothing but 1 by 2 Laplace transform of e of omega naught t plus Laplace transform of e of minus omega naught t. Okay, so which is equal to 1 by 2 1 by s minus omega naught plus 1 by s plus omega naught. Here it is 1 by 2. So s square a minus b, a plus b. So a square minus b square. So taking LCM, s plus omega naught plus s minus omega naught. So which is equal to s by 2s you will get in the numerator, cancelling this s square, s by s square minus omega naught square. So this is what your resultant for an hyperbolic sine and cosine. Next one is damped sine and cosine function. We are going to apply. Damped is nothing but multiplying with the exponential function. Now I am going to perform for the sine omega naught t. That is sine function. This is one is exponential. It is a damped function. So here Laplace transform of e power minus at. So apply the formula e power j omega naught t minus e power minus j omega naught t divided by 2j. Okay, now take Laplace transform for this. So here first 1 by 2j is common, take it outside. So Laplace transform of e power, here combine these two form. Okay, so here minus take outside. So a minus j omega naught t minus e power here minus a plus j omega naught t Okay, now this is the Laplace transform. I'm going to apply Laplace transform for this 1 by 2j. So instead of a, I'm having a minus j omega naught t. So 1 by s minus, sorry, here it is minus, so it is plus. So a minus j omega naught minus 1 by s plus a plus j omega naught. Instead of a, I am having this term. Okay, now here take LCM 1 by 2j. So what you will get is 1 by 2j. Here s plus a minus j omega naught into s plus a plus j omega naught. In the numerator, s plus a plus j omega naught minus s minus a plus j omega naught. Okay, so here all these term will get cancel, so you will get 2j omega naught. So denominator you are having 2j, so you will have omega naught. So this can be written as a and this can be considered as b. So a minus b, a plus b. So it is a square minus b square. So j square, so it is omega naught square. So this is what the Laplace transform of damped sine function. Similarly, I am going to find out the for cosine function. So just you try it. So the damped cosine sine, sorry, cos omega naught t is, here it is Laplace transform of e power minus at into e power j omega naught t plus e power minus j omega naught t divided by 2. So here when you take Laplace transform of this, so this can be written as e power minus a minus j omega naught t plus e power minus a plus j omega naught t divided by 2. So when you apply Laplace transform for this, what you will get is, you will get s plus a by s plus a the whole square plus omega naught square. So this is what the damped sine cosine function. So the next function is damped hyperbolic sine and cosine function. Here we are going to multiply exponential with a hyperbolic function, that is sin h omega naught t. So when you expand this, you will get this term. So combining this term, you will get e power minus of a minus omega naught t minus Laplace transform of e power minus a plus omega naught t. So when you take Laplace transform, you will get omega, that is when you apply Laplace transform and simplifying this, you will get omega naught divided by s plus a the whole square minus omega naught square. Similarly, Laplace transform of e power minus at cos h omega naught t is equal to s by a, s plus a the whole square minus omega naught square. And another function you have to know, that is the Laplace transform of t power n is n factorial by s of s power n plus 1. I think already you have studied all these in your maths. So just I am recalling all this concept. Now we are going to directly apply all these concepts in our signals. That is, we are going to apply all these concepts in simplifying the differential equation. Okay. So now we will discuss about the properties. So here the same proof what we did in Fourier transform, the same procedure you are going to do for this. So this is what your tutorial. You have to solve all the properties and you have to get trained in solving all these properties. So first property is linearity property. So a f1 of t plus b f2 of t is a f1 of s plus b f2 of s. Okay, you need to prove all these properties. Next one is what? Time scaling. The time scaling property, you know, that is f of at is there. So its Fourier that is its Laplace transform is 1 by a f of s by a. So this is the time scaling property. Third one is time shifting property or time delay property, that is f of t minus t naught. Okay, so here is f of s e power minus t naught into s. There we have e power minus t naught j ohm, right? Instead of j ohm, here we are having s. That's it. Okay, the fourth one is frequency shifting property. in frequency shifting property, that is here what you will have is in frequency you will have f of s plus s naught. So similarly here you have e power minus s naught into t f of t. Okay, so this is what the frequency shifting property. There we will have j ohm plus j of ohm plus ohm naught. Here you will have e power minus j ohm naught t. Okay, next one is multiplication, that is multiplication by t of n, that multiplication by t of n. So here t of n f of t, its Fourier transform is minus 1 the whole power n dn by dsn into f of s. Okay, so this is also another property, multiplication by t, t of n. Next one is differentiation property, time differentiation. Okay, so here f dash of t is s f of s minus f of 0, and f double dash of t is equal to s square f of s minus s f of 0 minus f dash of 0, and f triple dash of t is equal to s power n minus 2, sorry, s cube f of s minus s square f of 0 minus s f dash of 0 minus f of 0. So f dash of 0, f double dash of 0. So this is what your time differentiation. So here there you will Laplace transform, we will have d by dt x of t is x of s we will have. In addition to this we will have some initial values. Okay, so this is what another difference between the Fourier transform and Laplace transform. Okay, so yes, this is the very important property, you need to remember this, because we are going to apply this property in analysis of signal. Okay, so another three important property is time integration, frequency integration, and convolution. Just remember the formulas alone. Okay, and we will apply all these in your signal analysis. Okay, so just go through all the concepts, and the next video we will see how to apply these Laplace transform in signal analysis. Thank you.